Muscular Strength, Endurance and the Placebo Effect, presented by Toby Busek. The placebo effect has long been a point of interest for the scientific community, and it was the 1955 Beecher study titled The Powerful Placebo that paved the way for 58 years of research. Experimental design has been adjusted to take the placebo effect into account, and while much debate remains, this research model is still considered to be the gold standard. Plainly explained by Coloca and Benedetti in 2005, the placebo effect or response is the outcome that follows the dummy treatment. In the field of sports science, research on the placebo effect typically focuses on outcomes which improve performance, Beatty and Photo 9. Improved performance from baseline measures was seen by both Clark in 2000 and Duncan et al. In 2009 for placebo groups when they were told they were being given a known ergogenic substance. With the market availability of nutritional products, supplementation is a common part of modern life. The meta-analysis of placebo literature on nutritional supplementation and performance concludes there is a positive effect, Rawdon et al. 2012. Classical conditioning may contribute to increasing the placebo effect where the subject creates an expectancy criteria, Montgomery and Kirsch 97. Evidence that nutritional supplementation works from previous studies may create a bigger expectancy criteria which may promote the placebo effect of inert interventions, Chromiak et al. 4 and Montgomery and Kirsch 97. So, a group of college-aged men were convinced of the power of an inert substance to improve their strength and endurance. Would a performance improvement be seen? Further, what if the participants were then informed the intervention did not work? Would that continue to improve their performance, remain the same, or decrease? So, it was the aim of this study to investigate the placebo effect on upper and lower body skeletal muscle strength and endurance in college-aged men. It was the hypothesis of this current study that the initial strength and endurance improvement will be observed from baseline following the placebo intervention, and then a plateau in performance with the removal of the placebo. The method. So 15 college-aged men were selected with a mean age of 23 years, 4.5 years standard deviation, a mean height of 1.75 metres and a standard deviation of 0.09, 80.8 kilograms and 16.2 standard deviation, and 14.2% body fat with a 5.2% standard deviation. A within-subject design was utilised to investigate the placebo effect on upper and lower body skeletal muscle strength and endurance in a group of college-aged men. We attempted to minimise the learning effect by familiarisation sessions of 1 rep max bench press followed by 1 rep max leg press, and then repeat maximal sessions at 80% of their 1 RM. After the familiarisation session, baseline testing was performed, and then subsequent testing sessions. So prior to trial 1, the participants were informed that the supplement they were being given was composed of a powerful amino acid that has been proven to increase skeletal muscle strength and endurance by 10 to 15%. We then went about removing the placebo effect by informing the participants that another university just completed an independent study of the supplement and found the supplement to have no effect on skeletal muscle strength and endurance. The supplement does not work. Here you can see the schematic of the study design, with initially the familiarisation session where we conducted informed consent, a health history questionnaire, and the familiarisation sessions I just described, and participants were given their placebo and a 3-day food diary. We then had a 4-day break and came back for baseline testing and recorded their demographic information, which I described previously, and conducted the 1 RM bench press, 1 RM leg press, 80% reps at bench press, and max reps at 80% leg press, 3-day food diary, gave them a placebo and explain how the supplement works, an adherence sheet, and a 3-day food diary. 4 days rest. Trial 1, same process of testing and measurement, except this time the participants were told that the supplement doesn't work. And finally, the trial 2 with the same testing protocol. We used the National Strength and Conditioning Association text, The Essentials of Strength Training and Conditioning, to develop our techniques and standards by which we deemed a successful lift. All the data was recorded directly by the testers into Microsoft Excel following each trial, and to determine if there was a placebo effect from baseline to between trials, a repeat measure analysis of variance was conducted for 1 rep max reps at 80% of 1 ARM, and also calories consumed. Where appropriate, a paired samples t-test post hoc was used to find between trial differences, and alpha was set at 0.05 for all statistical analysis, and everything was done in Excel 2007 results. So you can see from the table presented here the various means. I won't go into the details of that, but what we will discuss is where we had statistical significance. So you can see from the stars that both the bench press and leg squat 1 repetition max had a statistical significance between baseline and trial 1 and baseline and trial 2, but not for trial 1 to trial 2. And for the leg squat maximum reps at 80% of 1 RM, there was a significant difference between baseline and trial 1 and baseline and trial 2, but also no significant difference between trial 1 and trial 2. And for bench press reps at 80%, there was no significant difference. We also found no significance for the calories consumed. Discussion. The 97 study by Keenill and Kien provided quite a different bunch of confounding variables that might affect placebo studies. So we aimed to control those variables by minimizing the learning effect through the familiarization and participant selection with previous resistance training. We also ran statistical analysis on the calories consumed to make sure there wasn't any variables in diets that might have been attributed to changing in results. So the significance of the results for the 1 repetition max testing from baseline measures suggests that participant improvement was associated with a belief that they were ingesting an ergogenic aid, and this is in line with previous studies that have looked at this similar area by Clark and Duncan. On being informed of the treatment not being effective, there was no significant difference between performance measures, so that's trial 1 from trial 2, and these data suggests that the verbal information provided could negate an increase in performance, which is also shown by the Montgomery and Kirsch study. We had similar results for the endurance measures in the leg squat at 80% of 1 repetition max, but no significance in results was found for the 80% repetition max in the bench press. This could potentially be attributed to there being no upper body warm-up when compared with the Monarch warm-up exercise, but we do have 3 of the 4 measures supporting the research hypothesis. However, without a control group to compare the data to, it is difficult to draw conclusions about the strength and endurance gains and the placebo effect. Suggest that a future study following the same protocol with a control group not receiving a placebo intervention would provide stronger evidence to support the placebo effect in performance improvement and in strength and endurance in the upper and lower body. Practical applications. So the utilization of the placebo effect in performance enhancement brings into question serious ethical dilemmas beyond the scope of this discussion. So what coaches and trainers should focus on is the potential negative effects of routines or substances which, without being taken, an athlete may not perform at their best. So coaches and trainers should ensure athletes' confidence lies with their personal abilities, not with external substances which may or may not have any real effect on their performance.